Alright, so we've already looked at some calculated columns and basic measures in DAX. Now I want to shift our focus to a few essential DAX functions, specifically the aggregate and math functions like sum, average, max, min, and divide. These are some of the simplest and most commonly used functions in Power BI. Sum evaluates the total of all values in a column. The syntax couldn't be easier. You simply reference the numeric column you want to add up. Average works the same way. You point it to a column, and it returns the arithmetic mean of those values. With max, you usually reference a column as well, and Power BI will return the largest value in that column. But max can also accept a list of scalar values, just like min, which returns the smallest value using the exact same syntax. Now, divide is a little different. It performs division, but importantly it also lets you define an alternate result for scenarios where a division by zero would normally trigger an error. So the function takes a numerator, a denominator, and then an optional alternate result. Let's jump back into Power BI so we can build some measures using these functions. Remember, you can create measures in several places, but I prefer to build them directly in Report View, because measures don't physically appear in tables. The best way to explore their results is through visuals, like a matrix visual. I'll also right-click the table, or a field within the table to control exactly where each measure will live. To start, we'll build a simple sum measure. There are two measures I want to create, and the first one is cancelled quantity, the total cancelled quantity from the orders table. So, I'll right-click the orders table and choose New Measure. Power BI will open a placeholder in the formula bar that says Measure Equals. I'll name this one cancelled quantity, and the formula is simply a sum. I'll start typing cancel, and select orders, cancel quantity, that's the numeric column we want to total. Close the parentheses, press enter, and the measure is created. You'll see it appear under the orders table in the fields pane. But remember, measures don't show their value until they're placed into a visual. So, for example, if I want a third column in my existing matrix, I can drag in cancelled quantity, and Power BI will calculate it for every product number. Since the matrix is already breaking down data by product number, this gives us a valid view. Now you might wonder, couldn't I just drag the raw cancel quantity column into the visual and get the same number? Yes, you could. But that doesn't make the measure unnecessary. A measure like cancelled quantity becomes reusable in all kinds of downstream DAX calculations, like creating a custom profit metric or other business logic that relies on aggregated values. Now that we've created the cancelled quantity measure, and in the previous video, the total quantity measure, we can combine the two to build a new metric, cancel rate. To do that, I'll right-click the orders table and select New Measure. We'll name this one cancel rate. There are two ways to write this calculation. You can use the division operator or the divide function. Both approaches are valid, but remember that divide gives you an optional third argument for handling divide by zero scenarios. This is also a great moment to reinforce an important DAX concept, the difference between columns and measures. Measures cannot reference naked columns, meaning a column that isn't wrapped in an aggregation. For example, if I tried to calculate cancel rate using the raw cancel quantity column divided by the raw shipped quantity column, Power BI won't even let me select both columns. It knows that any expression inside a measure must evaluate to a single scalar value, which requires aggregation or an existing measure. That's why we rely on the measures we've already created. So our cancel rate formula is simply cancelled quantity measure divided by total quantity measure. Using measures inside other measures like this is absolutely standard practice in DAX. I'll press enter, and that calculation works exactly as expected. Next, I'll format the result as a percentage. Power BI defaults to 2 decimal places, which looks great for this metric. That's the operator version. To compare, let's also look at the divide function. Cancel rate equals divide, canceled quantity, total quantity, no sales. Here, the numerator is the canceled quantity measure, the denominator is the total quantity measure, and the alternate result is no sales. A much cleaner output for situations where a product has zero total quantity and would normally trigger a divide by zero error. When I press enter, the numbers refresh, and we get the exact same values as before, just with safer error handling. Now let's explore the results. At the moment, our matrix is showing shipped quantity and cancel rate broken down by product number, which is very granular. Let's simplify the view by removing product number and replacing it with category. This instantly gives us higher level insight. Right away, we can see that the categories with the highest cancellation rates, over 20%, are apparel, decor, and toys. That's a meaningful trend and something we could use to dig deeper into operational or customer experience issues within those categories. The last set of common DAX functions I want to walk through are average and max. Let's start with average. Suppose we want to calculate the average unit retail price. In the orders table, I can see a column called unit retail, so I'll right-click anywhere inside the table. Doesn't need to be the header, and choose New Measure. We'll name this measure Average Retail. This one's extremely simple. We just use the average function. I'll start typing. Unit Retail. Select it, close the parentheses, and hit enter. Power BI now creates that new measure under the orders table. Let's pull average retail into our matrix visual. You'll notice something interesting. Even categories or products with zero sales still show an average retail price. That's because, even for canceled items, unit retail still exists in the orders table. So the average function is simply averaging the values from the column, regardless of whether the items were sold. Let's go ahead and format this as currency. Now let's look at the max function. The logic is very similar. I'll right-click the orders table again and create another new measure. This one will be called max retail. We'll use the max function, start typing. Unit retail. Select it, close the parentheses, and press enter. That's it. We now have a max retail measure. I'll format this one as currency as well and add it to the columns in our report. Before we wrap up, there's one more feature I want to highlight. We've been using category as our row field, but we can add additional hierarchy levels, like subcategory, class, subclass, or even down to individual products. For example, I'll drag different levels, like subcategory, class, subclass underneath category. Visually, nothing changes right away. But now, we can use Power BI's drill-down controls. With these buttons, users can drill from category to subcategory to class to subclass, or even to products if we want to. This gives report viewers the ability to self-explore the data, move up and down the hierarchy, and uncover deeper insights, without needing separate visuals. We'll be talking a lot more about visual controls and other powerful tools in the report view in an upcoming video. So there you have it, how to create measures using common aggregate and math functions like sum, average, max, min, and divide. In the next video, we'll move on to time intelligence functions, which are some of the most useful tools in DAX. Thanks so much for watching, and don't forget to subscribe to stay up to date on future lessons.